piece of paper. Today we are going to talk about something called variation. Last class we talked about the average and named two things about the average that was pretty cool. What's the first thing? Where is the average? It's in the middle. Very good. And it provides what kind of information? Specific information. So because of that, if we're looking at our data, we're only going to know where the center of the data is. But there's other attributes about the data set as well. Another one is called variation. We've all heard this word before. So let's go ahead and discuss in our groups of two, what do we think variation means when it comes to data sets? You guys just have to be here.
Welcome to the group.
Maybe something like that.
I said a difference in output.
Yeah.
Yeah.
So I heard some pretty good answers. When we think of variation, we think of things being the same or different?
Different.
Different, good. So that's really what variation refers to in data set. Different, lots of different values. Actually, we can be a little bit more specific than that. How different are the values? So variation tells you how different the values are. So I want everyone to summarize that in their own words. I'm going to write what I wrote last time I did this lesson. But your answer should be slightly different than mine because we're all going to be summarizing everything in our own words. Yet everyone's staring at everything I'm writing. So to figure out how different the values are, you have to look at how they compare to one another. Or actually an easier way is how do they compare to one number in particular. That is called the mean. So remember, the mean is a central point, so we can look at how different the values are from the central point. So we're going to actually calculate the mean again. Let's go ahead and do that pretty quickly because we did the mean yesterday. I'm going to calculate the mean, you're going to calculate the mean. Hopefully we get the same answer. Okay, let's see. Maybe I'll get 5. Okay, good. But I said to label it with the correct symbol. What kind of means did we have in last class? We had 2 different types of means. The sample mean and a population mean. It's kind of hard to figure out the difference. How many of us think that this is a sample mean? How many of us think this is a population mean? Okay, all good guesses. Well, it was one of those, it was population. Now, the reason why it's a population mean is, what's the definition of a population? Who has to be there for it to be a population? Everyone. Is everyone in the family there? Yes, the younger daughter, the mom, dad, son, and older daughter. They were all there. So therefore, it's a population. So that's the way to figure out if it's a population or a sample. Can we have a sample from this family?
Yeah.
Yes, you take one of them out and now it's a sample, it's no longer a population. So we have to make sure we use the correct symbol. Tell me if I'm writing the correct symbol. Is this the right symbol for population mean? What symbol is that for? Sample mean. The population mean symbol looks like this. It's the Greek letter mu. So I explained that was how you pronounce the letter, and then one of my students had a thing for Pokemon, and I guess there's a Pokemon with that same name. So that's one way to remember it. I don't know, are you guys familiar with Pokemon, or is that like way past your time? Yeah, I think you guys, I think that's for more of an older audience. Okay. So go ahead and choose A, B, C, or D, and hopefully you're logged into Poll Everywhere. It's going to be a Poll Everywhere question. As soon as you're ready, choose A, B, C, or D. And we're 15 today. I'm going to go ahead and show the results. Good, that was the correct answer. So B, that's why the word average is kind of ambiguous and it can mean a lot of different things. In this particular case, the mean refers to the average of just those 5 people. Okay, so we can have small amount of variation, meaning values are close to the mean, or we can have large variation and the values would be far away from the mean. So, oh, I kind of got ahead of myself there. Okay, let's use that hint to answer the next question. If there is a large amount of variation in data set, then the difference between the value and the mean would most likely be A, B, or C. Take a guess if you're not sure, because at least by participating, you're on track. And C is the correct answer. Good, guys. If there's a large amount of variation, lots of different values, does that mean that they're going to all be the mean if we have a lot of different values? No, they're going to be far away. So if we want to figure out how far away everything is from the mean, what can we do to all the values? How do we find the difference between the mean and all the values? How do we find a difference? What's the operation of those differences? Subtraction. So what we can do to figure out how far away each of these values are from the mean, see how much variation there is, we can subtract the mean from each of these different values. So that's why we have an x minus mean column. What does x represent again? From last class? Do we have our notes? Let's get out our notes from last class.
Each value in the data set.
Good. So x should be each value in the data set. Did I put each value in the data set here? We have 2, 3, 5, 6, and 9. Is that each value in the data set? Yes, so to figure out how far away each of those values are from the mean, we're going to subtract what value from each of those. What was the mean? 5. So let's go ahead and do that. So, but do it in this column here because this is the minus mean column. So, go ahead and start within partners subtracting the mean from each of the values. Do is, because your partner was Rachel, why don't we move you over here and finish your David? So I'm going to start subtracting the mean from all of these. Anytime you have the mean, which is 5, and you subtract the mean from it, you get 0 because the mean is the mean. Now 6 minus 5 is 1, and I saw people doing a really good job here. But when you do 2 minus 5, you have to put -3. And 3 minus 5 is -2. So you have to make sure to put the negatives. Negatives are important. So what does it mean here? If somebody bowled a 3, who bowled a 3 again? The mom. The mom. So how did she do compared to the average? 2 below, good. The -2 represented the mom, bowled 2 below average. How did the dad do? His dad got a 0, so he got average. And what about the son? 1 above average. Good. So that's what those numbers represent. So X would just be each value. I don't want to write each value in the data set. I actually wrote something better because each value in the data set is a what? It's your what? What did you do to get the 2, 3, 5? What are those? They're each value in the data set, but they're also the number of what? Pins knocked over. Good. So you actually want to write number of pins here. And remember that this column here tells you how far away from the average you are. So what I wrote was number of pins away from average for the second column. And this tells us the variation, but if I'm running a report and I tell the person who I'm running the report that this person got 3 below average, this person got 2 below average, this person got average, this person got 1 above average, and this person got 4 above average. And our data set keeps going on and on and on and on and on. So I keep saying that. Is that very efficient? You keep saying, like, this person got this above average, this person got that. No, we can't really describe our data set by looking at each person individually because that's not going to be very helpful to our audience when we're describing our data. So what might we do with these values to look at how much variation there is rather than looking at them alone? So you'll see I made a column where I squared them, but it's not immediately clear on why I squared them. Yes. Good. Right now, if you're below average or if you're above average, does that really matter when it comes to variation if you're below or above? No, you're still different. If you're below, you're different. If you're above, you're different. Just like, well, this is a bad analogy. Just like if you're popular, you're different from average. And if you're not popular, you're different from average. So, so what we can do with all these values is if we square them, it doesn't matter if you're above or if you're below. So that's why I squared them. Let's go ahead and square them. So groups of 2, let's go ahead and square the values if we haven't done them already. It looks like we already did do that. Okay, so I'll just go ahead and square them. -3 squared, -2 squared, 0 squared, 1 squared, and 4 squared. 9, 4, 0, 1, 16. And why did I put a column total? Why do we usually add values together? So we can look at the total variation, but see the problem with that is when we add all the values together, we get 30. The problem with that value is that the more values you have on the data set, it's going to tell you it's going to say you have more variation if you just look at the total. But what we should be doing instead is we should take the total and divide by what? 5. Because then instead of looking at the total variation, we really should look at the average variation. There's not much point in looking at total variation. It's not going to be that helpful, or just making your data set bigger is just going to make your total variation bigger. But really, we want to look at variation on average in a data set. So we want to actually divide the total by 5. So if we divide the total by 5, we get 6. And so that's our average variation. Now I want to just point out that we still haven't filled in this box. Does anyone have a good interpretation for the x minus b squared box? I'll just give it to you. It's squared number of pins away from average. All I did was add a square in front. Now, we need to be using the correct symbols. What's the symbol that tells us to sum all the values? Sigma. So I need a sigma, but what am I putting in front of the sigma? What did I sum? X minus mu squared. So you have to write that in. And I want to write that this was our average variation. Now, what was this and what was this? Let's go ahead and in groups of 2 discuss again what was our sigma of x minus mu squared, what was our m, and then fill in the formula. So what was the top guy? 30. Good. And what was the capital?
So 6.
5.
5. Good.
Yeah, so 5.
So what was the sigma of x minus mean squared again? What was that? The column total. I'm going to color code these. This right here was actually this right here, which is 30. And what's capital N again? Population size. What's our population size? 5. Oh wait, that's the 5 over here. Didn't we already do 30 divided by 5? Yeah, we did. And that whole thing was what value? So 30 divided by 5 was 6. So that was just the summation of x minus mean squared divided by 5. We call that, we see here that that's called the variance, or it's an average variation, as we saw here. I said to apply the correct units, though. Does anyone know what the correct units are? So we can abbreviate it with pins, that's fine. But what happens when you have the pins and you did something to the pins? This was the number of pins away from average, but this one was the squared number of pins away from average. So instead of writing squared number of pins away from average, just put a little square on top here for short, like we do in algebra to indicate the values for squared. And we use a symbol. The symbol for the variance is sigma with a little square on top. So make sure to label it as sigma squared. Now, what kind of variance is this? Is it a population or sample variance? Why? Well, good. We took it from the population, and you'll notice that one way you can tell for sure is that there's a population mean in the formula. There's a population mean in the formula. If there's a population size in the formula, there has to be a population variance. So definitely indicate that in the note that this is a population variance. Now, this is now going to be another poll everywhere question. What does the variance, or in this case, the population variance, represent? Is it the average difference between each value and the mean? Is it the average squared difference between each value and the mean? Is it the difference between each value and the mean? Or is it the squared difference between each value and the mean? So A, B, C, or D. And go ahead. Let me see, what was the answer? I'm cheating today. It was B. So just change all your answers to B. It'll let you do it if you want. Okay, that's why I don't like to show this until after, because then everyone could just kind of cheat a little bit. Okay, so B was correct. Why is it the average squared difference? Good. You took the difference, then you squared it, then you took the average. Let's go through this one more time. we took the difference, then we squared it, and then we took the average. So it's the average squared difference. Okay, no one's looking at me. Okay, one more time. We took the difference, then we squared it, and then we took the average. So it's the average squared difference. I want us to all say average squared difference 2 more times. Difference. Well, I mean, distance is fine too, because you're generally looking at the distance as well. Okay, so we call that the variance. Why might I take the square root? What was the problem with our variance? We squared them, and what did it do to the units? It made them all positive, and then we ended up with pin squared. So we're actually going to take the square root to get rid of the pin squared. So go ahead and take the square root and see what value you get. Groups of 2. Compare answers. And just for a little fun, if you have the time, put your answer in the folder everywhere, but if not, that's okay. Okay, let's see what the results were. It doesn't do it right. You're right. I need to start using Kahoot. You know, the problem with Kahoot is that you have to make all.
Yeah, you have to like write marker.
I was going to say our university doesn't pay. They pay for this. Okay, so that it kind of showed the correct answer. When you take the square root, you're taking the square root of 6 pin squared. That's really what you're taking the square root of. If you took algebra 2, you remember that if you take the square root of something, you can distribute the square root so that you distribute it to both the 6 and the pin squared. And then that ends up being 2.449 and then just regular pins. So that's a little fun fact from algebra 2, is you want to square both, the square root of both. Okay, we call this the standard deviation. I want everyone to, I said to use the correct symbol. What symbol are we going to use? What was the symbol for the variance?
The little thing.
Sigma.
Yeah.
Okay.
That.
3, 2, 1. Sigma. Okay, I won't make it do it 3 more times. That's a sigma squared. So this one, because we took the square root, is just regular sigma. Good. We call this the standard deviation. Everyone write a really beautiful, oh yeah, question. Oh yeah, okay. So this is where our mathematicians kind of screwed up. They decided to use sigma for both summation and for standard deviation. The difference is this is lowercase sigma and the other sigma is uppercase sigma. In this case, the lowercase and the uppercase are not related, which is actually not helpful to us people that are learning. Unlike the capital N and the little n, those were related, but the capital sigma and the lowercase sigma are not related. They're just 2 totally different symbols. It's like orange and orange. Like an orange on the tree and orange is color. So this sigma, the little sigma, represents just standard deviation, and the capital big sigma just represents the unit summation. I wish I had better news for everyone. Definitely feel free to ask more questions. That was a good question. No one's actually asked me that before, so I'm really glad because that's actually fun. Okay, we are almost done here. What does it represent? Go ahead and write a great definition. The best definition possible that you think that
That's for number 11.
it's okay if you're wrong. But it's right. You guys can discuss your answers in groups.
This is the average deviation from the mean of a data correct value.
What did your group say?
The average.
Good, that's actually good. Okay, here's the best answer. But again, anyone can have a great answer. We said the variance was the average square difference. So when you take the square root of the square, it just basically cancels. So it becomes the average distance. So my definition was average distance between what? Good. Each value and the mean. Now the reason why I didn't say difference and I said distance is because we squared all the values and so that makes everything positive, and so distance is always positive but difference is negative. So I write here just to indicate that it's always going to be positive because the square got rid of the negatives. That's why we squared it, to get rid of those nasty negatives. I wanted to write that in red, but I wrote it in red, so you guys know what I meant. So if there's little variation in a data set, then this one is Paul everywhere. 2.45. You guys are getting very creative in your answers. So A, B, C, D. Give it a few more moments here to just choose something if we're not entirely convinced and I'm afraid to be wrong, but that way, like, if other people got it wrong, you know, there's a few people that got it wrong, not just one person. I'll bet you guys. And it's okay if it's wrong, because we're here to learn. Okay, so answer is yes, that was correct. Very good. So yes, the standard deviation will definitely be small, but the variance will be small too because both of them tell you how far all the values are from the mean. Which one's going to be bigger, variance or standard deviation? Variance, because it was squared. So even though they both tell you how far away everything is, the variance is going to be bigger because of the squares. But the further everything gets away, the bigger the variance and the bigger the standard deviation, the closer everything is together, the smaller the variance and the smaller the standard deviation. So good. Oh, and I already answered number 11. What's the answer to number 11? Did Good, it's a population standard deviation. What was the reason again? Does anyone remember? The symbols. You can look at the symbols, so please write, it's those symbols that tell us that that's a population standard deviation. Or some sort of version of that. And then, when we're ready, try to write a formula for the sample standard deviation.
So it'd be the same thing.
It may help to look at the activity from yesterday where we wrote the formulas for samples and the population. It's hard to know where I Okay, so I'm gonna fill it in. We're gonna do this together. Remember that sigma? We just had one sigma for population or sample, so that doesn't matter. What about x? Is there a different x for population versus sample? No, we saw yesterday that that's the same. What about the mean symbol? Is the mean symbol still mu? No, what symbol do we use instead? X with the bar over it. And then instead of capital N, we use little n, although that's actually wrong. Okay. This is probably this is actually the most important part of the class because the activity we're going to do next has everything. Mathematicians realized that if they used little n, they got terrible results. Because remember, the whole point of the sample standard deviation is to approximate the what? What do samples approximate? Population. So the whole point of the sample standard deviation is to approximate the population standard deviation. Well, they figured out that if you put an n here, you get terrible approximations. However, one person discovered that if you do a -1 on the bottom, that you get much better approximations. Oh, yeah, my bad. Thanks, Audrey. Don't forget about the square here. So, just the parentheses. So what we want to do is we want to make sure we take the mean away from all the values, then square all of them first, and then do. Oh, because we had a different symbol for sample mean than we did for population. Since we have a sample standard deviation, I can make sure we use the mean of the sample. That was a good question. Any other questions before we go to the computers? So in today's activity, we're going to be doing everything that we just did in Excel for both the population and the sample. So I'm going to actually kind of give you a preview first. So here's what your Excel document's going to look like. And you want to make sure you take the mean away from all the different values for each of these. So we have a population. First, we have a population. So you have to find the mean in the population first. And to find the mean in the population, just use the average function. So it's average and then parenthesis and then highlight all the values. And so when you do that, you get 248.1029. And then you can do the same thing here to do it in the sample, highlight the same values, get the mean, and then subtract the mean from each of the values. So remember, you do it with the first one. I would actually recommend typing in the mean. So actually type in 238, okay. Oh, I know it's wrong, I'm locked. 238.556, Still not right. 5, 5, 6. And then am I going to do that separately for each one? No. Do the drag down feature. And then what was the next step? What are we doing with each of the values? Squaring. Does anyone remember the symbol for squaring? The little caret thing with a 2. So do that and square all the values. And then add all the values up. But what was the little difference here? When it's a sample, what do we want to divide the total by? Well, we're dealing with a sample, so we still have if you look at the formula, it doesn't say population size, it says what would this little n represent? Sample size minus 1. What's the sample size? 1, 2, 3, 4, 5, 6, 7, 8, 9. So am I going to divide by 9 or 8? 8. So make sure to put an 8 on the bottom here. Now for this one, you're going to do the same thing. When I do it for the population, am I going to divide by 1 or n minus 1 or just capital N? Just capital N. Okay. Now to find this activity, you're going to go into connect bound.